Welcome to this Quantum Security and Defense presentation, Quantum Security, the case for symmetric key establishment systems, and thank you for being a valued member of our community. Mattia Montagna is the co-founder and CEO of Quantum Bridge Technologies, Inc., a company specializing in quantum-safe cryptography solutions. Prior to founding Quantum Bridge Technologies, Mattia served as principal financial stability expert at the European Central Bank from 2014 to 2019, where he built a group of quantitative researchers focused on the prediction of financial crises using large data, machine learning, and agent-based models. He holds a bachelor's and master's degree in theoretical physics, a PhD in quantitative economics, and completed a postdoctoral research fellowship in quantum physics at the University of Toronto. Mattia's expertise spans quantum and classical cryptography, financial markets, and monetary policy.
It's yours. I'm looking forward to your presentation.
Thank you very much, Anna, for the introduction, and very, very happy to be here. Thanks for inviting me. So my topic is about symmetric key establishment system. So let's jump directly into the main problem that I'd like to discuss. So the problem of key distribution is the problem of distributing a key to Alice and Bob, so two parties that want to communicate over an insecure channel like the public internet, right? So once they get the key, then the cryptography can be pretty much secure, even in the quantum world, maybe using advanced encryption standard or even going to information theoretical secure protocol like one-time pad encryption. But the problem of distributing the key securely to Alice and Bob, that is pretty challenging, and this is the problem indeed called key distribution. And normally this is performed using asymmetric cryptography. Now we know that quantum computers can actually attack the mathematics, the one-way function behind asymmetric encryption. And so in a world where the quantum computer exists, we need a new method, a new technology for performing key distribution. Now, if we think about what, let's say, families of technology are available to perform key distribution in a quantum-safe manner, the first one is what is called post-quantum cryptography, which is still based on asymmetric encryption, but the mathematics behind it is changed, and it's, let's say, it's resistant to currently known classical or quantum computer attacks. And I say currently known because asymmetric encryption cannot be proved mathematically to be information theoretically secure. So if you have enough computational power, eventually you can always break system based on public-private key schemes. But again, I mean, it's a great technology. This was standardized by NIST last year. Last year, they eventually announced the finalists. But because of the problem, let's say, that doesn't achieve information theoretical security, many people are looking at other ways to perform key distribution, right? A second way is quantum key distribution. This also received quite a lot of attention, at least at the academic level. But lately, actually, also in the industry, we see more and more companies offering commercial QKD systems. The first probably came up at the end of the 90s in the United States. Those are based on quantum mechanics. So the idea is to use properties like entanglement or no cloning theorem and so on to allow Alice and Bob to generate a key between each other. At the security level, they perform pretty well. However, system right now still rely on the need of either an optical fiber that connect directly Alice and Bob. So you need to have a dedicated fiber between Alice and Bob to use QKD system, or a satellite link. And those are pretty expensive systems to deploy, to maintain, and so on. Regardless that, so QKD achieve information theoretical security. So if you use it and you use it properly, and the system is implemented properly, then you can be safe against any future attack. And then there is a third category, which we can call symmetric key establishment, which was largely overlooked, in my opinion, in the past years in the context of quantum security. And symmetric key establishment are based on the pre-share, is based, let's say, on pre-sharing random data. And I will show you a couple of examples of this category.
Watch the full presentation and more than 50 hours of other expert presentations, access courses, and become a member of the community. Simply search for Quantum Security Defense.